if you remember this, we built this in a couple lectures ago. So if you still have it, you can bring it up on your own. If not, go back to that lecture and you can draw it up. And I'll put the link to it in the notes. But what we had here is we had a localized stress right in this area. And I want to look at that a little bit more using our knowledge now that we have about meshing. So I have this part saved, and I'm just going to use my SOLIDWORKS integration. If you don't have it, I want to keep it in my current version. All right, so let's take it over to ANSYS. If you do it in a step file, it should be fine. So I'm going to set up the same study that we had done before. So a static structural study. And I'll link the geometries, click and drag it over. Just use the steel that comes by default and go right in to do the working on the model here. There, so there's our part. And let's go ahead and apply the boundary conditions and solve it real quick. So the material is just, I'll use the structural steel, it's fine. And so for the boundary conditions, we want support, a fixed support on this end. So we'll apply that. And then on the other end, we want load pressure. And we'll do 1000 PSI. I have to check the units, so it's PSF. Let's change it to PSI. That looks good. All right, and go just with we'll find out the mesh here a little bit. Go to find mesh, and let's go ahead and solve it for von Mises stress, and solve that out. All right. So, and this is, by the way, this is a distorted image. Hopefully it's obvious that it's distorted, but it's trying to give you a sense of what all is being deflected as it moves. If you come over here to result in the scale, it's auto scaling it. So if we go back here and go true scale, we can actually see how far it actually does deflect. So that's true scale. And then if we want to look at no deflection, undeformed, we could go to that one. I'll just go to true scale because that'll help when I switch between, because I want to compare this result here that I have versus the mesh. So this is our overall mesh. Let's just zoom in right here where we see the high concentration of stress there. So if I go back and forth between stress and mesh, I want you to notice something. So notice all this red right here? Right? The only information that this model has right now is at the nodes. 1, 2, 3, 4, 5, 6, 7 nodes across there. And so if we go back here, we should see 1, 2, 3, 4, 5, 6, 7. So wait, there's only information at the nodes. There's only information at this. So notice where this red line is. Notice what's right underneath it. Right? Just nodes. So there's no nodes actually in between here and here. So it's doing an average. It's doing an average between those two nodes, basically using the shape functions that we've talked about in the past to average what they think is happening between those two the two sets of nodes that we have information on. So is this really what's happening? And so that's why this is a key point where you want to go and dig deeper and use a more finer mesh. So we're going to do that. We're going to use a different type than the last one. And come up here. So I'm clicking on mesh so I can have access to my mesh control. And I'm going to click on mesh control. I'm going to do some refinement right at that area. So I'm going to click on that surface. And just that surface, we're going to compare this to what happens, and apply that. We're going to compare what happens here versus what happens down here at this surface. So we're not going to do anything with this one. We'll just look at what happens up here at this one. So let's zoom back in here. One face, and we'll say refinement. We're going to turn this up to 3. So let's see what happens. It'll be easier if I just show you. So update, and look at the mesh results. So remember, it's a relatively uniform mesh. And now let's see what happens after we've done the refinement. Wow. So right there, it's refined mesh right in that area. Can I click off here? There we go. All right, so notice how the rest of the mesh isn't really affected, but locally, right, we get a much finer mesh to basically figure out what's happening in this gradient. There's a strong sudden change in stress right in this area, and we want to see what's going on there. So we've just added, doubled, maybe even tripled the number of nodes we have across this span here. So now let's solve the model and see what we get. And so now we still got a bunch of big red spots, but let's see where that's located at. Let's see what the mesh looks like underneath it. And there's a bunch of nodes right in here. So again, it's still averaging in between nodes, but we have it's almost brought those two lines that we had before and brought them into being much more kind of this one stress concentration right in the middle there. Let's see what happens at the bottom. So I'm going to shift this over here, hand this over, and I'm going to go to two windows so we can do a nice little comparison. So let's do two vertical viewports. So here's the one, top one. Let's go look at the bottom one. See, there's no stress. I mean, the highest stress we're seeing, so both scales are the same. So it's a big thing you want to key in when you compare something and make sure your scales are the same, especially because these colors are just at the whims of whatever you make your scale to be. So we can see that the max probably even shows up in here. Nope, it's not. Do that. Do it over here. Show me the max. There it is, right there in the middle. All right. If we go from the side, yeah, right there on the surface. All right. So we can see how it affects this side versus this side. And let's again look through two different meshes here. So very fine mesh versus a very coarse mesh. All right, so that's the key point when we do mesh refinement. Not just here because our license is limited, because our license, we can only do 256 nodes or elements, 256,000 nodes or elements. But any time you're doing computational analysis, you want the thing to run as fast as it can, so you can do as many models, different iterations, and solve things quickly. And so when we do the mesh refinement, we want to do it in areas where there's high gradients, where things are suddenly changing. So in this case, over here, actually both cases here, we had sudden changes. Like see the yellow out to green changes very rapidly. Whereas if we zoom out, right, the rest of the body can have a much coarser mesh because the stress isn't changing suddenly. There's going to be enough resolution with the node spacing there throughout the rest of the part than there is right in these places where you have stress concentrations. So that's where we want to make sure we have mesh refinement. And I've shown you one way to do that this time. If you want, and everything else is working, you got plenty of time, and you got the computational power, we could just make this whole part have a finer mesh, and I showed you how to do that with the glass in the last example. All right, so if you have any questions, let me know in the comments. But I hope that was informative, and I'll see you in the next presentation.